Thank you very much for taking the time to meet with us here at IBM Research Center.
My pleasure.
And first of all, I would like to ask you to explain to us, what are you doing here? You and many other colleagues who have been working for so many years, they contribute a lot through their scientific developments, contributions, insights. Can you just summarize a little bit why this center is so important for IBM and also for the rest of the world, because some of the very important technologies are developed here?
So our goal at IBM Research can be summarized in really few words. Our goal is to create the future of computing. Computing that has been foundational to human evolution, human understanding, I would say broadening human impact, because every process in the world can be in some ways formulated through physics and mathematics, which are so closely intertwined together, which results in the foundational nature of computing. And you can trace the societal progress that has been made, especially since the dawn of, I would say, digital revolution in 1940s, from IBM itself, and then starting with 1960s in this building where we are meeting today. From the very first digital computer being created, from mainframes that are the foundation of the entire financial transactions world, to really the personal computer era, to the era of internet and artificial intelligence, and now to the era of what we call really the next revolution that is upon us on quantum computing. So our goal is always to watch out for what's next in this building and IBM Research broadly, but we are proud to be sort of the flag bearers for being the headlights for not just IBM company, but for the world. And it's really been underlined by, I would say we are very proud to have been awarded 6 Nobel Prize winners, 7 Turing Awards, which is equivalent of Nobel Prize in computer science, one that happened just a couple of weeks back. We have had a storied past, and we are looking forward to continue to lead the pushing the boundaries of computing.
Before we go into the quantum computing and the role that it plays in AI as emerging technologies, I would like to focus a little bit on your role. What is the burden that you have through your role to make sure that scientific progress constantly happens and that all of your scientific members of your teams are in the same direction, and how you coordinate with everybody, and what is the day-to-day work that you have to do to be successful?
That's a very nuanced question, I would say. So my role as the chief scientist of IBM Research is to really watch out for the technical strategy of not just IBM Research, but for IBM company. I have a sort of a fairly broad role as a vice president of IBM Technology as well, to really formulate, build a consensus around, and really work with the broader set of teams to execute on that technical strategy. Now, as you might imagine, by its very nature, it's a very broad role, actually. Mm-hmm. And for that, you really need to have experienced different levels of abstraction of technology yourself as well, actually. I personally am not a fan of you are talking about something, but you don't know what you're talking about. Mm-hmm. There are people who are talkers and there are people who are doers. I would like to be in the camp of doers. I am lucky enough to have sort of really spanned almost every level of abstraction in the entire information technology and computing stack, all the way down from radiating chips, silicon chips in the basement of this building to see how they will behave if they went in space, to really working on materials and technologies for designing those computing chips, to really building algorithms to automatically design those chips, so building software to automatically design those chips, to using those chips in systems which are AI systems. When I sort of overtook as CTO and Chief Architect of Watson, to accelerating workloads with GPUs, I would say 12 years back, when NVIDIA was not a big company then, to really working on AI applications. And now more recently, working on agents. And I would say, in 2021, I envisioned that software engineering will be totally disrupted by AI. This was way before ChatGPT was on the world stage. So having worked through the entire abstraction level, it certainly enables me, I would say, to bring these diverse set of technologies together in a way through almost a personal experience. I would say I've been lucky enough, and I really consider myself blessed in the technology area to really bring this diverse set of technologies together. There are not that many people who have had that diverse set of experience, and that gives me a unique, I would say, sort of empowerment to be able to connect these two diverse set of things, but also to be able to work with these teams as well, not just as a, and I'll use the word, not just as a program manager, but really as a deep thinker who can debate with the teams. They can debate with me, we can poke each other, we can push each other, and that particular role is a unique role which, because of its cross-cutting nature, needs to bring these diverse set of ideas together for formulating the technical strategy of IBM Research, thereby what's next for IBM company. And again, as I said, I think I've been in a unique position, and I consider myself blessed, but also working with the community as well. This is not just a sort of inside looking role. This is also a role for working with other chief scientists across the community, across academia as well. So I've had roles in academia at different leading universities, and the work we do in working with some of the more other leading institutions across this country and the world as well.
For young professionals, because I've seen you also have given advice to young professionals who wants to follow this career path like yours, you can be the example for a young professional to reach out to this level of success that you have at your role. What is the advice that you would give? You mentioned something about the importance of doing things, not just talking, and especially talking about the things that you don't know or you don't understand. How important it is for the young professionals to understand first this industry. And the other element that I got from your response before was the diversified experience. Diversity, how much important it is, and are you comfortable that the younger generations are focused on this element of diversification, of diversified experience?
I think you bring up an excellent point, I would say, that
your answer gave me the motivation for this follow-up.
In the age of AI, I really believe something that will become quite fundamental to human contributions and understanding will be this cross-cutting nature. I think AI will become very good at depth in certain fields or in a diverse set of fields. But when it comes to cross-connecting a diverse set of ideas together, I think human ingenuity still carries and will carry for a long period of time an upper hand. And it will be AI working together with sort of this diverse nature of creativity that will be sort of the human contribution to progress of knowledge. I really believe it, actually. Now your point on, is our next generation or the younger set of professionals really well positioned? And I would say, given the set of tools that are emerging in these areas, even more so than ever before, they are empowered to learn more. Because learning has become, if I just go back to almost like historic times, you needed to have a, really, I would say, a particular person where you can go and learn from. That person was very rare.
The mentor.
Yeah, the mentor. Like think of it as elite internships. You will go and do, really be a mentee of someone. Then the education become more diverse, I would say democratized. There were institutions that came along, but again, those institutions were elite. Through the innovations of latest set of AI tools, best and the most capable education is available on demand, anywhere, everywhere. You can be in the remotest parts of Africa or Asia or anywhere. You don't need to be at MIT and Stanfords of the world to get the best possible education. The burden, I would say, is on us, especially young professionals, because they are growing up in this era of AI, which is fundamentally transforming not just how we learn, but how we work. So they are growing up in truly a transformative time. And the burden is on them to not just talk, but learn about these technologies in a hands-on way, and amazing capabilities are available for them to learn. In fact, I would say for many people, including me, by the way, who don't get as much time, if I just go several years back, to be able to code as much. Like these set of capabilities are enabling me. I've had ideas actually, like it's almost like having an intern available to you all the time, every time actually. And they keep on working. You have an idea, you can specify an idea, and you can iterate with them. So if it enables, I would say, very busy people to be able to interact with them and code even, become more hands-on, it really empowers young professionals to amplify themselves 10x, sometimes 100x. And I would say, like, I'm just going to quote something. I just saw an article yesterday in New York Times on, small is the new big. It used to be that big teams can move mountains. It's becoming more so that small teams can move mountains actually, because the small teams are enabled by these massively powerful capabilities through which you can learn, you can create, and you can action.
Correct me if I'm wrong. I believe that you had mentioned the importance of having the artificial intelligence applied to now, to see the real impact now. I have the 1% of the knowledge you have, and maybe less. So I don't want to pretend that I'm an expert on the issues that you are the top leader to explain. I would like to have a little bit of your help on understanding the difference of what I've read online, and many other colleagues of mine are reading about the difference between the artificial general intelligence and the artificial useful intelligence. What is the difference? What is more immediate, and what you invest more right now, if there is a difference between these two terms?
I think I'm personally a huge fan of useful, because useful is here today. Useful I can get value of today, and we are investing all massive amount of capital, both I would say financial capital, intellectual capital, sort of our time capital as well into it. But lot of industry, I would say, and lot of journalists actually, they're enamored with this topic on artificial general intelligence, super intelligence, you name it. And although it's sort of, I would really say a exciting goal from a humanity perspective, implications can be very deep actually, but there are problems to be solved today in day-to-day business life, in day-to-day personal lives, in day-to-day, I would really say, consumer life as well, where AI can make a big difference today actually. And before we all get enamored by what it can do to mimic human intelligence. And I'm going to sort of quote something on that point just as a relation to this particular question. Before we get all enamored by how close we are to human intelligence, I want to see how useful these technologies are today. And for example, in the case of software, I think it really enables me to bypass some of the more mundane things that most software developers don't want to do. They have to do it because it is part of their daily job that they do, actually. It enables them to focus on things that are more creative, focus on problem solving more than implementation itself. Implementation is means to an end. Problem solving is a very creative endeavor. So it enables them to focus on things that are creative and get real value out of it in software development. For example, in IBM, we've been developing a coding agent called Bob, which has been rolled out across 60,000 developers in IBM, 60,000 actually, enabling their productivity to increase by 45%. Useful. Is it general intelligence? No, not yet. But then on the other hand, I would argue I care less about it. And now let me come to the point I mentioned earlier. If we really want to measure general intelligence, then we should really look at what cost. What is the cost of general intelligence that we are trying to develop actually? So whenever there is something called artificial intelligence, and whenever we say the word artificial, there must be something real, right? That's why the word artificial does not exist without real. That real is between these two ears in a space of 1200 centimeter cube. So this space consumes 20 watts, the power of your phone light, and runs on sandwiches. That's real. That general or that artificial runs on GPUs, and a single GPU board from NVIDIA, one board actually, consumes 1200 watts. And to get anything close to general intelligence, even remotely close to it, you're going to need thousands of them. So you are looking at a difference of energy efficiency of orders of magnitude. So before we say we are close to achieving real, at what cost? No, this is, I joke it often, this is engineering. This is not physics. In engineering, it's always about cost efficiency. Everything is possible in the world. Given the energy of sun and the energy of universe, potentially everything is possible. I think it's very important to keep in mind the perspectives of what cost for the society, what cost of computing, and because, to be honest, most enterprises and most companies in the world do not have a market cap of $5 trillion.
Yeah.
They are backbone of world's economy, whether it is Procter & Gamble, whether it is Caterpillar, whether it is Disney, you name it. Companies across the spectrum of world's financial system. They don't have the benefit of just consuming cost like crazy, and therein lies the usefulness of the AI as well. That usefulness is also governed by not just by what I can do, but what cost I can do it at as well. So general intelligence is almost a theoretical question. Then you should superimpose energy, which is kind of the physics boundaries actually into it. What can you do today with real intelligence, and can you reproduce it? Not just quality, but can you reproduce it at the cost real intelligence does it? And the second one is on, if you can't, then let's talk about useful. And therein comes the perspective of cost then. Because, my pocket is fixed in size. I just maybe somebody's is not, but most people's pocket is fixed in size. Therein lies what can be done in enterprises, given a quality I achieve, minimize the cost for it. And that's what we are really focused on as well here at IBM, on not just achieving useful, I would say, not just achieving quality in enterprise use cases, but also achieving cost efficiency as well. because that enables enterprises to build it in their business processes that they can roll out to the broad set of cross-section of society.
And IBM is known to provide enterprise solutions, not consumer solutions, if I am right. You provide the expertise to enterprises, right? And you are caring about the cost. The mentioning that you mentioned about the cost is a priority of how you develop something and how you know the cost of the effort to apply this in practical terms.
Absolutely. So I think our goal is first to develop a set of technologies that enterprises can integrate in their solutions, that we work with them collaboratively towards, understand their problems, collaboratively work with them on rolling that out as well to really help them derive value. The key word I would say is value out of the technology. Value is obviously driven by you must achieve a certain quality. Otherwise, the issue of cost is immaterial. It's like a car you buy but put it on your driveway, but it doesn't drive. That doesn't help actually. So you need to achieve a certain quality, but then you need to optimize the cost. And I'll give examples of set of technologies we are working on in that domain. It's well known that the frontier models do an amazing job, whether it is from Anthropic or whether it is from OpenAI or Google DeepMind and others as well, do an amazing job actually. But not every enterprise use case needs the frontier model capabilities. Maybe if the enterprise use case spans, let's say 0 to 100, maybe 5 to 10% needs deep reasoning. The other things can be done with smaller, more efficient models. Purpose-built, domain-specific, smaller, more efficient models. We work on efficiency of the models. We work on fundamental research for the architectures. Our Granite series of models have been improving, specifically are targeted towards more enterprise-specific use cases. And we've been making steady progress towards that goal of making AI more efficient. So those are the kind of things and capabilities we work on to make AI more efficient, more consumable, and more valuable for the enterprise solutions and use cases.
And what are the major breakthroughs towards that direction? Like, what is the concrete accomplishments you can bring up as an example of the things that has been successfully applied the last few years, if you can name?
So I would really say there are I would like to point out few fundamental set of things actually. One is actually, and we did it more recently in our what we call our Granite, our 4.0 series of models, is around a technology, and I'll elaborate on this a little bit more, is what is known as state space models. Think of it as a AI model architecture that enables you to compress information more efficiently in a smaller footprint of the models, because the memory of these models can be a lot. They need a lot of memory actually, which becomes more costly. To be able to compress their, I would say what is known as model weights in a smaller set of footprint, which enables them to be much more efficient. This was one of the more fundamental breakthroughs of how we combined and evolved a model architecture from a traditional, what is known as transformer-based architecture, combined with what is known as state space models together. And the goal was really to develop more efficient set of models. That's first one. The second one I would say will be in the area of what we call uncertainty calibration. Let me describe what I mean by that actually. These models kind of hallucinate a lot as well. This is well known, that you ask them something, and when was the last time anybody had an experience with the model telling you, I don't know? Almost never. It always answers you. And if you say, no, I think you're wrong, they'll say, oh, I am sorry, I really didn't mean it that way, I think you are right. Like anybody who has worked with ChatGPT will tell you the same experience actually. I say it with all sincerity, knowing what you know is information retrieval. It was in your memory, you retrieved it. Knowing what you don't know is intelligence. And in my mind, for these models to be able to calibrate their own uncertainty, not just answer something confidently, but to be able to calibrate its own uncertainty is a critical part of really these models becoming much more intelligent. And we've been adding those set of technologies and breakthroughs to our series of models as we have been evolving them over multiple generations. And we are almost getting into our sort of, between fourth and fifth generation of our models. The next one will be, I would say, really around having a set of technologies, what I'll call guardrails. These sort of models can be, having bias in them. We at IBM have been very specific around responsible AI. And these models are tremendously powerful in their capabilities, but also, the creators of these technologies also have a lot of burden on them as well. All of us have a lot of burden as well to make sure they're not biased, they're not drifting. There are certain set of guardrails actually. So we've been working on what we call our guardian set of models and capabilities, which is integrated as part of our model architecture as well, to ensure these models are do not hallucinate, they are not biased, and enterprises are able to define a set of guardrails around them as well actually. So we have specific actually capabilities around detecting abuse, profanity, all kind of things, which is fundamentally integrated in the model. Not just that, but for enterprises to be able to define what those guardrails are for the outputs and the insights. Including drift, when these models start drifting from their desired goals, and all of that is another set of technologies and breakthroughs that I believe we are one of the world's best in. We've been working in this area for last, I would really say, decade and a half, starting with the machine learning models in the beginning, and more then deep learning technologies, and then generative AI technologies. And then finally, I would say, I would close with that. We've been working on a set of technologies which I'll call consistency. What I love about rules or deterministic systems is I can trust them. Like if they give me one answer today, I know that answer will hold. The problem with some of these newer set of generative technologies is, I would say it's a blessing in disguise, or it's a double-edged sword, that they are amazingly powerful, but they are statistical as well. And because they are statistical, they can be sometimes inconsistent. And if they are inconsistent, then enterprises cannot trust it. I want something to hold so that I can trust it all the time. So consistency of models actually led us to what we call programmable. How do you program these? So the way you program these models, or you get some tasks done, is through what is known as prompting. You prompt them, you get some output. Now prompting can be, you can ask question one way, I can ask question another way, and the output will be very different. How do we put sort of more programmatic sort of context around these prompts is a topic of deep research in the community on what we call programming model of these prompts. That's another area we've been working on, the set of teams that have been doing this work, a capability called Malia.
So that means when you say consistency means that when you pose a question A and you pose a question B on the same topic, to have consistent answers.
Yeah, so when you pose a question A, you pose a question A.
In a different way, you pose a different...
And I pose a question A in different way, I get different answers.
That's true.
So that's what I mean by consistency. As long as the question being posed wasn't similar, I'll get kind of different answers depending on how you pose that question. Your style of posing it is different than mine, and I get different answers with different contexts sometimes actually. And consistency is all about what enterprises need more than anything else is consistency. I'm going to trust you with that answer, and trust relies on consistency.
How close are we to accomplish these goals of consistency, of responsible AI with the guardrails to make sure that there is no bias, there is no misuse of the interpretation that the AI applies on every single fact?
So I would say, I think one of the most critical aspects to, how close.
In how many years we think that we're going to be in a high-scale position of reaching the excellency on these topics?
So I would say, from the perspective of what we were discussing earlier, useful AI, we are there today.
Yeah.
That we have a set of technologies. I'll give an example of that technology. We have something called watsonx governance, where you can take the use case you have, integrate it with our governance set of technologies, what we call agent ops, which is how do you operate these agents once they are deployed in practice, and how do you continuously evolve them. Their integration in practical use cases and making those set of technologies useful, we are there today. Now, looking at this from a broader where the technology is going, is all of this integrated as part of the model out of the box? No, not yet actually. So we have think of it as we have a set of technologies that a user or an enterprise can bring to bear and integrate many different set of technologies together, agent building frameworks, agent operations framework, governance frameworks, all of those together, and guardrails to really roll out something useful at scale that helps you get the value you really want with the set of responsible AI traits that you really want, including bias detection, drift detection, hallucination, and all of that. Ideally, I would like all of these set of technologies to be incorporated as part of the sort of out-of-box AI technology that we are building as well. We are not there yet. Plus, I would really say, responsible AI is very contextual. It depends on the user. What one treats as responsible is irresponsible on the other side. Right. So we need to give this flexibility to the users in any case. I don't think we can define,
on behalf of the users.
On the behalf of the user, what responsible actually means. It really varies from user to user. What is responsible in one use case is irresponsible in the other use case. So those set of technologies have to be loosely coupled actually. They can't be so tightly coupled that I am defining the responsibility for you. I have to give that particular capability to the user. But overall, I think we are on a journey to accomplish I would say the minimum set of requirements needed to start to scale the AI. We are there today. Now, in terms of as AI continues to mature and become more and more powerful with agents, that's a journey we are on, because we are heading in a world where agents will start to collaborate with other agents autonomously. I like this word on what is known as agency of agents. There's agency of humans. How much of empowerment do you have as an individual, as a enterprise member, and so on. Soon we will be talking about agency of agents. How much agency you give to an agent. The more agency you give to an agent, which is the more empowerment you give to an agent, the more autonomous they become, and the more they can collaborate with other agents. We are not there yet at all in terms of governance of that, all of that together. That we will call multi-agent systems. You may have heard of something called OpenClaw, which has been a lot in the news lately, which is all about agents communicating like on a social media, on a social platform, different agents collaborating with each other. That's a very interesting and a very powerful concept, although the issues of security, the issues of governance, the issue of agency of agents, who is monitoring them, all of that are very open questions for which we are not there at all. This technology is moving amazingly fast, and one thing we all must do is make sure we are rolling it out in a responsible way, actually, because these set of technologies are incredibly powerful, but also can be very risky as well, actually.
I'm sure that someone in your position and with your skills and expertise and career, one of the main characteristics of your personality is to be visionary, to contemplate the future. I think it is necessary. How you contemplate the future for the next 30, 40, 50 years, when the new generation of experts will be sitting in your position, what do you think the person in 50 years from now who will be in your position would have to face as bigger challenges? If you can answer this question, but I have always this, concern about the future, and I'm sure that you have the same concerns from your responsibility and your important role.
So, I am an optimistic person by nature. That's very foundational to me being me. So I usually carry a more optimistic version of the future, and I believe in overall that by and large humans, have good intent in mind. And yes, I think there are lots of questions on these technologies, but I also believe somebody sitting, in my position or other positions where strategy is being decided, I think in my mind they'll be blessed that they will have capabilities that are only discussed in science fiction today. I truly believe science fiction will come true. I remember my wife is a physician, and I remember discussing this with her, roughly maybe when we were doing way back when sort of Watson Health and other things, that science fiction will come true, and we're not there yet, but I think we are getting closer and closer to it, which implies we will be able to answer questions to which we do not have answers to at all today, actually. We'll be able to understand human body much better. We'll be able to understand causes of the diseases much better. We'll be able to understand how, the nature of physics and the nature of how we are here better. There are some fundamental questions to be answered, which someone sitting in this chair 50 years from now will be blessed to hopefully have at least answered, if not all of it, I do not believe all of it, but a significant part of it. And that will enable them to, I would really say, I and many others here are standing on the shoulder of other giants, Nobel Prize winners, Turing Award winners, and we are the beneficiary of what they have created. Hopefully, all of us will be providing that benefit to future generations. Somebody sitting in this chair who would say, thank God that was done then. And they will be able to predict the future much better than I can today. I would say, I do my best, but I only have access to, I'm using my brain. I think 50 years from now, somebody will be using their brain, and they'll be enhanced by million other brains, actually, at their fingertip. Think of it this way. And that gives you a capability which is truly mind-boggling and unprecedented for decision-making and prediction to solve some of the society's most fundamental problems. And I think it's not just about AI. I think I wanted to bring sort of the context of something that we are working here in this building, which we started the discussion with, to start the future of computing.
That's right.
Discussion on. I think the set of technologies that are coming together on quantum computing, working together with AI, are resulting in a fundamental shift in the computing model, which is almost like a bifurcation in a road, actually. The classical systems are heading this way, and with quantum, their trajectory changes, actually. Because what you can do is you can start accelerating scientific discovery in fundamental ways when these two set of technologies start working together. And I think we can discuss an example of that, but that to me is so foundational to somebody sitting in this chair, many decades from now. Because right now I have access to AI capabilities. I would really say still relatively primitive AI capabilities if I just project multiple decades from now. Somebody here would have access to not just incredible sense of almost real intelligence at their at scale real intelligence at their fingertips, but also the ability to compute with nature itself at their fingertips as well, to be able to create new material candidates. AI can create a lot of material candidates. You can filter them, and quantum computing can simulate that. And then you feed it back to AI. So now you create this AI quantum sort of really accelerated discovery loop, as I call.
Why you think that the general public, I think some part of the reason is the role of the media. They don't hear about the quantum computing. They hear about AI, they hear about this terminology, everybody talks about AI, but it's not broadly recognized to the general public, not to the experts, the role of quantum computing.
Yes,
why? Is it because for the experts this terminology, or it hasn't been communicated? Like the general public doesn't seem to have engaged the terminology and the meaning.
I think I would really say it's about where the maturity of technology is. Since we were talking about projecting ourselves sort of multiple decades from now, if I look at sort of the real applications of quantum computing, the technology we are talking about, it's going to be in materials discovery, it's going to be in drug discovery, healthcare area, financial area, and many others as well. And those set of applications are starting to emerge. The first thing is to work on fundamental sort of hardware and software technologies, which we are doing. But AI is at every technology, when it emerges on the world stage, has a journey to take. Quantum is at the beginning of that journey, I would say. We predict it'll be really in the mainstream, impacting applications in 3 years or so now, actually, when what we call fault-tolerant computing, quantum computing systems emerge. Fault-tolerant meaning these systems currently have a lot of errors. Mitigating errors is foundational part of computing. If your system has a lot of errors, you can't do useful things with it. We predict in 2029 that will actually come together. And that really is, think of it as sort of that supernova explosion. That's the starting point of that explosion, which AI has gone through, actually. Now, I would really say the beginning of that was 8 to 9 years back from now, when transformers and the set of architectures came together, the deep learning and the transformers, so roughly a decade. AI has had the benefit of a decade. And to be fair, the word AI itself was coined by several IBMers being in that meeting, in Dartmouth, not too far from here. So it has had a long journey. Quantum computing is emerging, and the reason I would say general public, not the scientists obviously are getting more and more on the point of, I think this is getting real. More recently, there was a lot of press on cryptography and how that we need to rethink where we are on the timeline and all of that as well. But it's not yet getting to a stage of, where general public needs to care about it, other than enterprises need to start worrying about it from a security point of view, cryptography and security point of view, which they better start now. Because the traditional cryptography, which has been foundational to the software and applications and security of all of these applications and data, is at risk if these, all the companies do not start acting with what we say, quantum safe cryptography. that set of technologies that we have worked on for many decades here.
I would like to conclude our conversation starting where on a point you mentioned at the beginning about the fact that right now everybody in every point of our world have access to information and can learn things and improve himself and amplify the skills and the prospects of success. There is, on the other side, a huge concern about how this AI and the emerging technologies will transform the job market. Would you say that it is on our hands as humans to remain relevant in whatever job market transformation occurs, in whatever changes in the job market emerging technologies apply?
So I would say, again, I'm going to lean on, I am an eternal optimist, and I'll back that up, actually. I really back that up. Here is a prediction. I believe there's a lot of fear-mongering going on. There are people who have said, very established people, big figures have said, by 2030, 80% of jobs, entry-level jobs will be lost. That figure has been quoted, actually. I actually take the opposite view. I take the view of, I think people who are at entry-level jobs just writing software today, let's say they work for IBM, Microsoft, Google, a lot of big technology players. We are at a golden era of this technology where this technology is getting democratized and it's going to go into every industry you can think about. Every industry, actually. Whether that happens to be transportation, whether that happens to be healthcare, whether that happens to be finance or IT or every industry. If this technology goes into every industry, either it just rebuilds from kind of itself. We are not at that point yet. Nowhere close, actually. So engineers will be needed to build agents in all these industries. It's just not going to build by itself, right? Somebody is needed to build these agents. I think a lot more jobs will be created because right now the set of jobs are very confined to technology industry. This technology has not yet percolated in every industry yet. If the prediction of what people are saying, this is going to impact everything, comes true, then engineers are needed to build those as well. The data quality is very poor. Actually, one thing that we didn't discuss yet is this set of technologies need to integrate an existing world. I wish the world was pure. It's not pure at all. It's very messy. My systems are very messy. Most enterprises you look are still living in one would argue 3 decades before software. So they're not, the world is not pure. And engineers are needed to integrate these modern set of technologies in a old era, if I may say. System of records, legacy systems. Therein lies the explosion of jobs, actually. So yeah, they may get more reduced in technology industry, I get it. But then they're going to be, I'm going to pick same set of examples, they're going to be Caterpillar, they're going to be John Deere, they're going to be in Colgate-Palmolive, they're going to be in Unilever. You name it, they're going to be everywhere, actually. And that, to me, is really one of the most important aspects of us democratizing the impact of this technology, and not just gives me hope. We will find out. I'm confident. I think all of this fear-mongering on jobs will go away. I think jobs are going to explode. And this set of technologies will be no different than every technology that has come before it. I go to the beginning of when the wheel was invented. Before that, somebody was carrying weight on their shoulders. Yeah. Did that job go away? Yes, that job went away. But did we as humans stop evolving? Obviously, our productivity has gone up, our GDP has gone up. We've just continued to sort of go up and up in terms of our productivity and our advancement. I firmly believe these set of technologies will be no different, but even higher in terms of how much it will boost our productivity and how much it will move our society forward. Because there are set of challenges to be solved in our society, from climate challenge to healthcare challenge to really equality as well. So I think this is absolutely the stepping stone to solving those fundamental societal problems.
We thank you very, very much for your time and for our conversation today.
My pleasure. Thank you.